Good day, guys. I hope you're good. So, on today's episode, we are going to deal with empirical and good day, guys. I hope you're good. So, today we're going to deal with empirical formula and molecular formula. Okay? Chemistry, paper 2, quantitative aspect of chemical change. So, we are still dealing with stoichiometry in essence. Okay, guys. Definitions involved for empirical formula and molecular formula individually. So some of you guys might define empirical formula as the simplest whole number ratio of atoms in the compound. We'll talk about it as we proceed. So we're going to talk about ratios, we're going to talk about whole numbers here, and I'll show you as we proceed. Then for molecular formula, it is the multiple of empirical formula. That means it is the multiple of empirical formula. You will see that when you want to find the molecular formula, there will be wherein we are going to multiply by 2. In most cases, we multiply by 2 to reach to the molecular formula. It will depend, by the way, guys. Yes, so please use definitions in your guidelines. Guidelines, they provide with proper definitions. They use them for these two terms, empirical and molecular formula, in preparation for your examinations. Now, guys, let us start with one example. Number 1, determine the empirical formula of a compound that is 25 gram nitrogen and 74.1 gram, let me just say oxygen. Now, determine the empirical formula of a compound. Empirical formula, very important, empirical formula of a compound that is 25 gram nitrogen and 74 gram oxygen. It's very simple. So now, for you to determine the empirical formula, you ought to first determine the mole. Number 1. Number 2, the ratio. Number 3, the calculations. These are 3 concepts that you need to go through for you to reach to finding the empirical formula. Number 1, determine the number of moles, N, for these 2 atoms, nitrogen and oxygen. Okay. So guys, here is 25.9, 25.9 gram. Yes, not 25, it's 25.9 gram. Yes, it's a mistake. Now let us find the number of moles of each atom, nitrogen and oxygen. Nitrogen. So this number of moles is equals to a mass number over molar mass. This is equals to, what is the mass number for nitrogen? Is 25. So it's going to be 25.9 divided by, what is the molar mass for nitrogen? You go back to your periodic table and check for the atomic mass of nitrogen. You guys give 14. Then you put this on the calculator. You say 25.9 divided by 14. Okay, it's going to give me 1.85. Okay, guys. Then you are done with the number of moles for nitrogen. You come back to the number of moles for oxygen. Number of moles for oxygen is mass number divided by molar mass. What is the mass number for oxygen? Here we are given 74.1 divided by, what is the molar mass for oxygen? You come back to the periodic table and look out for the atomic mass for oxygen. Keep going, 16. Yes. Then you say 74.1 divided by 16 here. On a calculator, it's going to give me 4,63125. Now, the second step is finding the ratio. Okay, remember the ratio there. Now, what is the ratio for nitrogen is to oxygen? Ne? It's very simple. What the number of moles for nitrogen is 1,85. And what is the number of moles for oxygen is 4,63125. Now, to find the ratio between these two atoms, you need to divide each ratio by the lowest, by the one with the lowest value between the two. We can have 3 atoms here, but if you want to find the ratio, you must divide each part with the lowest ratio. Between the two, which one is low in terms of value? Is 1,85, and yes, therefore we must divide each and every ratio by 1,85. Each and every ratio. So it will 1,85 both sides, and here 1,85, and here then 1,85 divided by 1,5. 1,85 divided by 1,85 keep 1 here. 1 is 2. What is 4,63125 divided by 1,85 keep 5. The answer there is 2,5. Now guys, remember when here's a trick. When it gives you commas, it's like it gives us 2,5 here. It's very important to understand something here. Now, let me just say you divide here and it gives you, let me just say, 2,9999. And you must write it in a whole as a whole number. So 2,999 is 3, and it's exactly 3. When it's 2,9 is 3, it can be 2,9, it's going to be 3, and but if it says 2,8, it can be, you can say 3. You must multiply something here. I'll show you what you're going to do. When it's 2,5 here, you must do something. When it's 2,2 here, you must do something also. It must give you literally 2,9 at least. 2,9. But right now it is giving us 2,5. So when it gives you 2,5 like this, now I said 4,63125 divided by 1,85, and that gives me 2,50337. And that answer, you multiply it by 2. Multiplied by 2, and when you multiply the whole value times 2, it must give you a ratio, a whole number of 5. This is going to be equal to 5. That's how you do it. When it gives you silly commas, when it gives you number after this true, there are commas there multiplied by 2. Multiply that number all the time by 2. Irrespective of what that number is, multiplied by 2, it must give you a whole number. That's our aim in this case. So the answer here is 5, guys. It's 5, not 2,5. It's 5. So we multiplied by 2 again, so we get 5 there. I hope you guys understood it. Now we are done with finding the empirical formula here. What is the atom for nitrogen, or how many atoms do you have for nitrogen? Is 1, again. So you're gonna write N here. Is 1. How many atoms of oxygen do we have? 5, again. So you're gonna write 0,005. Here's it, NO5. That's how you write it, guys. I hope you clearly understand what is happening here. An acid contains 1,59% hydrogen, 22,2% nitrogen, and 76,2% oxygen. Determine the empirical formula. Now here's a question like this. An acid contains 1,59 hydrogen percentage, 22,2% of nitrogen and 76,2% of oxygen. Determine the empirical formula for this. Very simple then key. Now we've got 3 atoms here, or 3 elements there. And you remember the first rule I want to go back the mole again, number of moles. Second rule go back ratio. Then the last one again, calculations. So now we need to find the number of moles for each atom, for nitrogen, for hydrogen, nitrogen and oxygen. That's our aim here. Now calculate the hydrogen, the number of moles for hydrogen and mole. So number of moles is equals to mass number over molar mass. What is the mass number for hydrogen? By the way, this percentage means capacity, or the mass that it consists of 1,59. This 1,59 percentage is the same as the mass number, which is 1,59. 1,59 divided by, what is the molar mass for hydrogen? You come back to the periodic table. What is the atomic mass of hydrogen? 1. 1. Then the answer there is 1,59 mole. What is the number of moles for the next atom? Which is Which is nitrogen. What is the mass number of hydrogen? It's 22,2. 22,2 divided by, what is the molar mass for nitrogen? Remember, molar mass, it's our atomic mass on the periodic table. What is the atomic mass for nitrogen? Is 14. Therefore, you press the calculator, you say 22,2 divided by 14. Then the answer there is 1,5857 mole. And then the last one, number of moles for oxygen. Then the mass number divided by molar mass. Then what is the mass number there for oxygen? Is 76,2 divided by molar mass. You come back to your periodic table. What is the atomic mass of oxygen? Is 16. Then the answer there, you say 76,2 divided by 16. Then the answer is 4,625 mole. This is the final answer. Then you are not done, by the way. You are done with finding a mole. You come back to the ratio here. You are doing the ratio with thing. You do the ratio thing. Very simple. The ratio thing is very simple, guys. Hurry, ratio. Here we've got the ratio for hydrogen. We've got the ratio for hydrogen. We've got the ratio for nitrogen. We've got the ratio for oxygen. These are 3 atoms we have here. Now, what is the number of moles for hydrogen? Is 1,59. We just found it here. Excuse guys. Is 2. What is the number of moles for nitrogen? Is 1,5857. What is the number of moles for oxygen? Is 4,7625. Yes, I don't have space here. Now, remember, when you got ratios here, for you to find the whole, remember you need to find a whole number here. For you to find the whole number, you need to divide each and every ratio by the one with the smallest value between the 3. Which one between the 3 has got the smallest value? Is it 1,59, 1,5857, or 4,762? Which one has got the lowest value? Is 1,5857. Again, guys, that's 2. Therefore, we're going to divide both sides, all 3 sides, by 1,5857. Then the second one is 1,5857. Then the last one is 1,587. 1,5857. So now the first one key, 1,59 divided by 1,587 857. Then the answer there, I just find 1,00, that means it's 1 there. It's good that 1 is 1, is 2. This one, because this 1 is to 1. I get 1,587, they're the same. So it's 1 there. It's 2, 4, 4,7625 divided by 1,5857. Then the answer there is 3. And here it gives you 3,00. That means it's 3 there. So it's going to be 3. Therefore, you are done with finding the empirical formula. You write it in a proper, you write it as a formula there. So what is the atom? What is the atom for hydrogen? And here's another hydrogen there. What is the atom for hydrogen? How many atoms do you have for hydrogen? Is 1 atom. So you write 1 here. How many atoms do you have for nitrogen? We've got 1 atom. You write 1 there. How many atoms do you have for oxygen? We've got 3 atoms of oxygen there. Then that's how you write it. This is the empirical formula, guys. You are done with finding the empirical formula. I hope you understand what is happening here. Let's go to the next part of our lesson, which is finding the molecular formula. The question says, calculate the molecular formula. Very important molecular formula of the compound whose molar mass, very important, molar mass is 60 grams per mole, and the empirical formula is, so we are given the empirical formula here in this case. Remember, we just found the empirical formula here. In the previous videos, we literally wanted to find the empirical formula. Right now, you must find the molecular formula. We are given the empirical formula. It's very simple. The molecular formula instead of what? Instead of empirical formula. Very simple, guys. Now, here in this case, we are working with molar masses. It's not a mistake that they give you the molar mass for a compound which is reacting with it's not right now they've given you the molar mass. It's not a mistake that they've given you the molar mass. You are given a molar mass, and its empirical formula is CH4n. Now, there's a difference between the molar mass. This is the actual molar mass. Then this one is that one of empirical formula. It's why this one comes from the empirical formula. That means you need to find the molar mass of this compound that comes from the empirical formula. So there's a difference between the molar mass. This is the actual molar mass. This one is the empirical molar mass. It comes from the empirical formula. I hope you understand. So molecular formula works with molar masses only. So you must divide 2 molar masses to find the molecules. Then you must multiply. Remember, in the definition for molecular mass, it said you must multiply the empirical formula. So you are going to multiply. After you have divided the molar masses of this compound and molar mass of this one, then you must multiply the answer with this formula. I will show you right now. So now we need to find the molar mass for this one. So molar mass 1 to CH4n. Okay. What is the atomic mass of carbon? 12. You say 12 plus. What is atomic mass of hydrogen? 1. Carbon has got 4 atoms here. You're gonna say 1 times 4. What is the atomic mass of nitrogen? 14. Therefore, you're gonna say plus 14. Then you put this on a calculator here. So you're going to say 12 plus 4. 16. Then 16 plus 14. 30. So it's going to be 30 gram per mole. This is the answer for this one. Now, for us to find the molecular formula, we need to divide the bigger number with the smallest one. The bigger molar mass with the smallest molar mass. Which one is between the two is bigger? Is this one. Therefore, we're going to say 60 divided by 30. 2. That means here we're finding the molecules. two molecules. So you're working with two molecules here. Ne? Now, with these two molecules, you are going to multiply these two by each atom we find in the empirical formula. And in the empirical formula, I've got CH4N. So you're going to multiply each and every atom by 2. Then you're going to say, so I guess that's why atomic 1 monana, and 4 another 1. So you're going to say this 2 times this 1, this 2 times this 4, this 2 times this 1. It's going to give you the molecular formula basically. So glory C1 multiplied by 2, H4 multiplied by 2, N1 multiplied by 2. So it will C2, H8, N1, N2. This is the molecular formula. This is the molecular formula. This is how you find the molecular formula. Very simple, guys. I hope you can see it. So guys, here's a homework. Here's a homework, guys. There are 2 homeworks here. A material is found to be composed of 38.7% carbon, 51.6% of oxygen and 9.7% hydrogen. By other means, it is known that the molecule weight 62 grams. Calculated the empirical and molecular formula for this compound. So you must find the empirical formula and the molecular formula. Here are answers. This answer is for empirical formula. This one is for molecular formula. So you need to reach here. You need to reach here first and come here the last. The second question is nicotine contains 74.02 C. C for carbon, 8.710% H for hydrogen, and 17.27% for N for nitrogen. If 40.57 grams of nicotine contains 0.2500 mole, what is the molecular formula? Here's the molecular formula. This is the answer. When I work it out. Thank you very much.